Hello and welcome to the next lesson of the series Master the Elastic Stack. All you need to get started with the Elastic Stack. We are covering the third topic in the course outline, setting up security, which is very important. And from the learning objectives, we need to be able to set up security for the Elastic Stack. So in this demo, we're going to set up security for the cluster. The Elastic Stack has many different components working together. The data is being replicated between the nodes. Kibana is sending queries to Elasticsearch. Beats and logstash send data to Elasticsearch to be indexed. Elastic agents and other clients are sending data to the cluster. All of these components need to be secured so that we avoid any malicious behavior. Now, after version 8, security is enabled by default on Elasticsearch. From the previous video, we installed Elasticsearch and Kibana. Certificates were generated by default, but in this video, we're going to create new certificates and manually configure security. Elastic defines 3 layers of security that can be applied to a cluster. And this illustration is from their official documentation. We have the first layer, the minimal security, which is enabling user authentication and setting up passwords for the built-in users and password authentication for Kibana. This is not recommended for a production cluster. The second layer, the basic security, which is configuring TLS for the inter-node communications. This is where we need to create certificates to encrypt data between the nodes, but traffic between Kibana and the cluster is unencrypted. The third layer adds on to the basic security and secures the HTTP traffic from Kibana and the beats to Elasticsearch. This is recommended for a production cluster. Now, where do we enable security in a cluster? In the Elastic Stack, they define 2 places where we can apply security. First, we have the transport layer or interface, which secures the inter-node communications. Nodes are replicating data between each other, and to protect the cluster from an unauthorized node joining, we can secure this transport layer with TLS. The second place is the HTTP layer or interface, which secures data from Kibana and the beats and different clients to Elasticsearch. Both of these layers in the Elastic Stack context use transport layer security or TLS, but in the Elastic Stack terminology, they call them the transport layer and the HTTP layer. To secure this communication, we need a certificate authority, a CA, that can sign certificates for each of the nodes. In a production environment, you usually use an internal CA to sign those certificates, but in our demo, I'm going to node 1, generate a CA, and then generate the node certificates and apply them to each of the nodes. Now we're going to the CLI and start on node 1 and create a CA, and then create node certificates, and then go to each node and apply on the YAML file the different configurations and point to those new certificates, and then apply the settings and secure the cluster. Now here's what we're going to do. On node 1, we'll generate a certificate authority, a CA, then use that CA to generate and sign new certificates for nodes 1, 2, and 3 that will encrypt the transport layer for inter-node communications. So here on node 1, we'll go to the installation directory of Elasticsearch, and here we have this tool, the certutil. We're going to use this utility in the CA mode. So we'll type CA after, and this will generate a new certificate authority. And here it's going to ask us to enter the desired output file. I'm just going to accept the default file name, and we'll enter a password. And if we clear the screen and go back 1 directory up to the Elasticsearch directory here, we can see this CA is created right here, elastic-stack ca.p12. This file contains the public certificate for your CA and the private key used to sign certificates for each node. Now we'll use the cert util again to create a certificate. So in the cert mode, and we'll point to that CA in USR or user share elasticsearch, and it's called elasticstack CA, and we'll press enter, and it will ask to enter the password for the CA. It will ask to enter the desired output file, elastic certificates p12. I'm just gonna press enter, and we'll enter a password. Now we'll copy this certificate to our configuration directory under etc elasticsearch, and we have a directory for our certificates. I already copied it there, so I'll just say no, I'll cancel that, and we'll go to the etc elasticsearch certs, and I'll just list what we have there. And here's the new certificate. I'm just going to fix the permissions, I'll add the elasticsearch user for this certificate, and I'm going to also fix the permissions and give the user read-write permissions. And now we have read-write permissions for the elasticsearch user for this certificate file. And now we'll edit the elasticsearch YAML file to point to that new certificate that we just created. And there's a setting here. We have the default certificate created automatically, and it's under the XPack security transport SSL settings. And I'll just grab the name from here, save this file, and because we entered a password when creating the node certificate, we'll store the password in the Elasticsearch key store. So we'll go to user share Elasticsearch binary, and with this tool we will add the password. Say add, and we'll add this password for the transport SSL key store password, and we will overwrite because we still have the default password, and also for the trust store secure password. We'll overwrite, type in the new password. So far we created a certificate authority, and we created a new certificate signed by that CA for the transport layer to secure and encrypt the internode communications. Now we have to take the new certificate and copy it to nodes 2 and 3 and do the same thing. Basically copy it to the certificate or the configuration directory of Elasticsearch under the certs directory. We'll change the permissions for that certificate file. We'll edit the YAML file on each node, and we'll change those passwords. So basically this certificate here on node 1, I'm just going to copy it to nodes 2 and 3. And we'll go to nodes 2 and 3 and change the settings. Now back on node 1, we will stop and restart the Elasticsearch service. And after it came back up, we'll do the same on nodes 2 and 3. And on node 3, and back on node 1, we can just double check the status of Elasticsearch that came back properly, and it is active. So far we set up security for the transport layer or interface. So now we have secure inter-node communications. Now next, we're going to set up secure HTTPS traffic. This will encrypt traffic between Kibana and Elasticsearch on the HTTP layer or interface. We need to stop the Elasticsearch service on our nodes and the Kibana service. So node 1 will need to stop the services, node 2 same thing, and then node 3 as well. I'll just hit the up arrow key and stop the service. And on the Kibana server as well, we need to stop the Kibana service. Now back on node 1, we need to use the cert utility in HTTP mode. We'll go to the installation directory. We'll use the cert util again in HTTP mode. We press enter, and it's asking us if we want to generate a CSR, a certificate signing request. If we have an internal certificate authority, we would generate a CSR, take it to the CA and sign a new certificate. But in our case, we're not going to generate a CSR, and it's going to ask us if we want to use an existing CA. We're going to say yes, user share elasticsearch, and it's called elastic-stack-ca.p12. We'll enter the password for the CA, and it's asking for how long should your certificate be valid. I'm just gonna say 5 years, and now it's asking if we want to generate a certificate per node. We'll say yes, and we'll start by typing in node 1 name. Mine is es-01. And now enter all the host names that you need, 1 per line. And when you are done, we'll press enter again. So these are my nodes. And you enter the following host names. Is this correct? Yes. And enter now all the IP addresses that you need, 1 per line. So I'm going to enter the IP addresses of my nodes, 101. So these are my 3 IP addresses I'm going to use, or for my nodes. Is this correct? I'm going to type yes. And now it's asking if we need to change any of these options. I'm just going to say no. Generate any additional certificates. I'll say no. Now it's asking to provide a password for the certificate file. I'm just going to enter a password and confirm it. And the file name that we want to use for this output zip file, I'm just going to accept the default here, elasticsearch ssl http.zip, and the zip file is written to this location. So I cleared the screen, and here on the home directory, I'm going to unzip this new file, and I already zipped it. So I'm going to get these 2 directories, Elasticsearch and Kibana. And if we look inside Elasticsearch, and we get this HTTP p12 certificate file that we're going to use in our nodes to encrypt the HTTP traffic between Kibana and Elasticsearch. So we'll copy this file inside Elasticsearch to our configuration directory, and we will overwrite the default one. I just kept the same name, that's why it's overwriting. And I will use secure copy to copy this file also to nodes 2 and 3. And if we look at this search directory, this is the new file that we just copied. And then I'm just going to the YAML file to make sure we are pointing to the file under this setting here. And it is the same name as before, but now we have a new certificate file. So we'll save this file, and then we'll add the password for the private key to the secure settings in Elasticsearch. I'll use the key store utility to add this password: xpack security http ssl key store secure password, and we'll override the old one. And we'll do the same for nodes 2 and 3. I'll just add this password. We already copied the certificate file to the correct configuration directory. Now we'll start the Elasticsearch service on all nodes. Now after we started the Elasticsearch service on nodes 1, 2, and 3, I'm going to check the status, and it is active. And now we want to encrypt the HTTP client communications for Kibana, and also encrypt the traffic between the browser and Kibana. In the previous step, when we generated the HTTP certificates, we got this directory for Kibana, so I'll open that, and we have this certificate that will encrypt the HTTP traffic between Kibana and Elasticsearch. So we'll copy that to Kibana, and we'll also generate a server certificate and a private key for Kibana, and this will encrypt the data between the browser and Kibana. So we'll go to user, share Elasticsearch binary directory, and we will use the cert util. But this time we will generate a certificate signing request for the Kibana server. It says please enter the desired output file. I'll just accept the default csr-bundle.zip, and it will generate this file in this location. So I'll clear the screen and unzip that file. And now we have this directory, Kibana server. And if we check that directory, we have a CSR created. And I'll go back to the installation directory to use the cert util to generate a cert, this time in PEM format. We'll point to the CA, which is under user share Elasticsearch, and it is called elastic-stack-ca, and the name is Kibana-server. It's asking for the password for the CA. We'll enter the password and enter the desired output file. Certificate bundle.zip is okay. Press enter, and now we have this certificate written, or it's inside this zip file, and we will unzip this file here, and we'll check the Kibana-server directory. Now I have a certificate file and the key. So now on our home directory we have a certificate for the HTTP layer that will encrypt HTTP traffic between Kibana and Elasticsearch. inside this directory, and we have a server certificate for the Kibana server and the private key that we will use to encrypt the data between our browser and the Kibana server. So we'll copy both of those to our Kibana server. And we'll copy everything inside Kibana server, which is the certificate and the key, to our Kibana server. Now moving to our Kibana server, we'll check the certificates that we just copied. We have this certificate and we have the Kibana server certificate and the private key. Now we will need to edit our YAML file to point to these certificates. Now the first one we need to change is right here, the elasticsearch.ssl certificate authorities, and it's this one, and the server certificate and the key should be right here under server SSL enabled. We need to set it to true, and we will point to the certificate and the key, and they are under etc Kibana. So when I unzipped the certificate file for Kibana, I unzipped it under the user share elasticsearch binary directory. So I moved the correct files now to Kibana. So CRT and the key. So I will edit the Kibana YAML file under here. I'll get the CRT file and the key file, which is very similar to this one, just with .key. I'll save this file, and after that I will start the Kibana service. System controls, start Kibana. And to check the status, looks like it's active and running. And now on a web browser, we'll browse to the Kibana IP address with the port 5601. This is where the Kibana service is running on, and with HTTPS. And we will get this warning in the browser that this connection is not private, because the browser does not know the local CA that we use to generate the Kibana certificates. This is a lab environment. In a real production environment, the CA is imported and the browser trusts it. So let's go to advanced. And we'll sign in with the Elastic user. And now we have secure access to our cluster. The three nodes are communicating securely between each other. Kibana is communicating in an encrypted tunnel to Elasticsearch nodes, and the data between the browser and Kibana is also encrypted. In this video, we configured security for the Elastic Stack by generating security certificates and applied them to our nodes and to Kibana to secure communications between the components. Now up next, we're going to ingest data into Elasticsearch using logstash and using FileBeat. Stay tuned, and I will see you in the next one.